Thousands of years ago in China, people experimented with something like fireworks. People would take a piece of bamboo, seal both ends, and toss it into a fire. As it heated up, everything inside would expand until it burst with a bang. They believed this noise scared away evil spirits. Later on, they amped up the excitement by adding black powder inside the bamboo, creating an even bigger bang. This primitive form of pyrotechnics laid the groundwork for the mesmerizing displays we see today. Now, let's delve into the chemistry behind gunpowder. It's made from 3 natural ingredients: potassium nitrate, sulfur, and honey. Potassium nitrate, obtained from bat and bird droppings, provides the oxygen needed for combustion. Sulfur, found in yellow crystals around thermal vents, acts as kindling, igniting the reaction at lower temperatures. And honey? It serves as the primary fuel, adding sweetness to the explosive mix. Mixing these ingredients creates a concoction that, when heated, bursts into flames. Quite the fiery spectacle. Charcoal, the unsung hero of the fireworks world. It's not just for grilling burgers, it's a crucial component of gunpowder. You see, in most fires, oxygen comes from the air. But in gunpowder, potassium nitrate supplies the oxygen, while charcoal provides the fuel. Charcoal's microscopic pores allow the reactants to mix thoroughly, enhancing the combustion process. Think of it as the spark that ignites the fireworks, quite literally. Now, let's talk about its chemistry. If the gunpowder mix is heated, it explodes like tiny fireworks. But it takes so long to ignite. Why? Well, honey contains water, which slows down the combustion process. That's why charcoal eventually replaced honey as the fuel of choice. It burns hotter and faster. By mixing sulfur, potassium nitrate, and charcoal in precise proportions, we get the perfect formula for explosive fun. Ever wondered why gunpowder explodes more dramatically when confined? The fascinating science behind the enhanced explosiveness of confined gunpowder lies in 2 key factors: concentration and heat. When the ingredients are confined, they are compressed tightly together, promoting close interaction and facilitating more efficient chemical reactions. Additionally, the enclosure traps heat generated during the combustion process, elevating the temperature within the confined space. This surplus heat amplifies the energy available for combustion, leading to a more vigorous and controlled explosion. To illustrate, imagine containing a wildfire within a designated burn zone. The controlled environment allows the fire to burn more intensely, resulting in a spectacular display of flames while ensuring safety within the defined boundaries. Similarly, confining gunpowder concentrates its explosive power, producing a dramatic yet controlled explosion that captivates spectators while maintaining safety measures. Crafting fireworks is a detailed process where art, science, and engineering come together to make stunning light shows. First, special mixtures are made with different ingredients like chemicals that burn, colors, and binders. These mixes are carefully measured to make sure they work right. Then, these mixtures are shaped into parts like stars or pellets. Stars are small balls that make colorful bursts in the sky, while pellets are the cores of bigger fireworks that shoot up into the air. After that, the parts are put together inside tubes or shells, depending on how they should look. Each firework is made with precision to light up at just the right time. Safety is super important during this whole process. Pyrotechnicians follow strict rules to keep things safe, often using special tools and places to handle the materials. Once the fireworks are built, they're tested to make sure they'll work well. This includes checking how high they go, what patterns they make, and how bright their colors are. Finally, the finished fireworks are packed up and sent to where they'll be used. Pyrotechnicians team up with event planners to plan out how the fireworks will be set off safely and in a cool sequence. In short, making fireworks is a mix of science and art, needing careful planning and skill to make the beautiful displays we all love. Launching fireworks involves meticulous engineering to ensure a spectacular display while maintaining safety standards. At the heart of this process is the mortar, a large plastic tube that serves as the launching platform for the fireworks. The shell, containing various pyrotechnic compositions for dazzling effects, is carefully inserted into the mortar. Alongside the shell, a bag of black powder is placed, serving as the propellant for launching the firework into the sky. This black powder, when ignited, generates a powerful burst of energy that propels the shell hundreds of feet into the air. In essence, the launch mechanism resembles that of a mini rocket, albeit with a focus on achieving artistic brilliance rather than reaching outer space. The pyrotechnician, stationed at a safe distance, orchestrates the entire display, synchronizing the ignition of each firework to create a harmonious and visually stunning spectacle. This process exemplifies human ingenuity at its finest, where meticulous planning, precise engineering, and artistic creativity converge to bring forth an exhilarating experience. The controlled chaos of fireworks displays embodies the thrill of pushing boundaries while ensuring the safety of both spectators and participants. When fireworks light up the sky, it's not just a dazzling show, it's a chemistry lesson in action. You see, when specific elements inside the fireworks heat up, they release colorful light. For instance, strontium salts give us vibrant reds, copper compounds create stunning blues, and barium salts produce vibrant greens. This happens because of something called quantum mechanics, which is a fancy way of saying that atoms behave in predictable ways when they're energized. Think of it like a painter choosing different colors to create a masterpiece. Each element in the fireworks acts like a paintbrush, adding its unique hue to the canvas of the night sky. So, the next time you're watching fireworks, know that it's not just about the pretty lights. It's also about the amazing chemistry that makes it all possible. Fireworks smoke can cause pollution by releasing particles and gases into the air, which can harm both people and the environment. These pollutants include tiny particles that can affect our lungs, gases that can form smog, and heavy metals that can harm wildlife. But don't worry, there are ways to enjoy fireworks responsibly while minimizing their impact on the environment. Some communities are using eco-friendly fireworks with fewer harmful chemicals and less smoke. Others are opting for alternatives like light shows or laser displays, which produce fewer pollutants. By choosing eco-friendly options and being mindful of how we celebrate, we can still enjoy fireworks while protecting the planet. So next time you celebrate with fireworks, think green and help keep the air clean.